Welcome back to Arcade. I am Super Tommy, and this is a series on creating a Sokoban or pushbox puzzle game in Phaser 3. So in the last part, we left off where we found a bug, and the boxes that we can push, let's show here, can push into other boxes, which is, of course, not right. Right? So the boxes that you can push should not be able to be pushed if there's another box next to it in the direction you want to go. And that should be, we can fix that relatively quickly, and then, I think at least. And then in this video, we should also cover when all the boxes have been placed onto the colored dots. So let's get started. First, I've got some whiskey here, some game dev and whiskey. This is Jack Daniels, Tennessee apple. Straight whiskey, non-flavored is too much for me, so I drink my whiskey flavored. Okay, now let's see. Let's actually run our dev server here. And what we want to do is stop the box or don't allow a box to be pushed if there is another box one more tile over in the direction that it's going. So let's see. So tween move is the function, the method we have that handles this. And so we don't actually know which direction we're going in tween move. So let's see, up. We can pass in a direction. That's perhaps what we should do. Let's see here. So if we pass in a direction, we could probably not even have base tween, since we always know you move 64 pixels. That's the size of our tiles. So let's think about that. I think that is actually plausible, but let's not make too many changes at once. We're going to call this direction, and this will be a number. And up here, rather, we have our constants. So let's make a direction.ts. So we could use enums here, and we'll just show you using enums in TypeScript. If you're using modern JavaScript, you can just make consts and then export all the consts. So what we did in color. So enum direction, and we're going to have left, right, up, down, and then export direction. We could export default, but we'll do export direction like this. Okay, so let's come back here. We are going to import from const direction, and we can just do direction. So if you are using modern JavaScript and you've done your direction more similar to this, right? Let's say you just set left, right, up, down, and you export it like this, you would want to do import star as direction from const direction. Okay, so direction. We can actually do that because of TypeScript enums. And so now we have a direction. Let's just pass it in here. We're going to do direction dot left, direction dot right, direction dot up, perhaps direction dot up, yep, and then direction dot down. So we will update this. I'm pretty confident that we can remove base tween and just deduce it given we know direction. Okay, so we got direction, get box data, brilliant. If there is a box data, we move the box, otherwise we move ourselves. So if there is box data, and we want to make sure that there's no, let's see, what do we call this? I'm going to call this is clear, maybe has room, has room. This, we have direction. Okay. So what I'm thinking is we need to figure out what we're going to, what the, what do you call it? The vector or the change in XY is going to be given the direction. So let's make a new function here, a new method. Let's not put it in the class. This doesn't seem necessary. So let's just call this all right, I'm going to call this tileutils, and this will import direction from const direction, import our direction enum here, and what we're going to do is, let's see, we want to get offset for direction, basically. Offset for direction, I don't want to rename that, but let's just call it offset for direction for now. Let me always be right, offset for direction. Okay, switch direction. So case direction dot left. And we will return new phaser dot math new dot point. I'm not actually sure which math dot geom dot point. But realistically, just return an object. That's the lightest weight thing to do, actually. So, okay, if we're going left, we're going to go, everything here is at top left, right? Minus 32. And then the y, because we want to start from more centered, we're going to go plus 32. And that would be left. So now case direction dot right, we're going right. So from the top left, we're going right. On the x, we need to go the full 64 to the right, plus 32, which gives us 96. And then on the y, it is the same 32. Case direction dot up. And in this case, again, top right. So up is going to be minus 32 on the y, but x will be plus 32, so that we're in the middle. And then y is minus 32. And then case direction dot down, return. So we're going down. We're going down. We're here at the top left. On the x, it's just 32. And then on the y, we need to go the full 64 and then 32, so that is 96. Why you complain? Read, run, return. And then in the default case, if for some reason we're given none of that, we're going to return 0, 0. And I'll just put that here like that. Export, offset for tile direction. Great. That looks good. We could, of course, specify tile size as 64 and then calculate half tile and do all that, but we'll see if we need to. Now you should also notice that these numbers are going to match right here. These numbers, right? Everything we're doing here is going to actually match, which should mean that we can remove all of this as well and just have direction. So we need our util. Let's put this up here, import from utils, tile utils, and we're going to get offset for direction. So back here, so has room, so we're going to get the, let's call it the next offset. It's like the 1 over, and we're going to do offset or direction, and the direction we're given is whatever was passed in. And so we have an XY here, that's what's passed in. Okay, so this dot get box data, so this is the next box data at X plus next offset dot X, Y plus next offset dot Y. So really I should call this next box data. And if there is next box data, that means there is a box 1 tile over from where we want to push. We are not going to push. We're actually not going to move. We're not going to push the box, nothing. Okay, so let's see how this works. So if I go left here, it should not let me. And it indeed does not let me. How about down? Good. Can I go left here? Nope. Okay, let's, can I push right? Right? Can I push up? I can't push up. That doesn't seem correct. Cannot push up. Let's go to the debugger. We're going to look at the line 160 here. And let's just see what it's doing right here. All right, so let's try to push up. I should be able to push up. Direction is 2. So 0, 1, 2 up, that's good. And then next box data, let's see, step over. So next offset, 32 minus 32. If we're going up, X is 32 minus 32. Sounds legit. So get box data. There should be no box. Box data. There is a box. Doesn't seem right. No, that's box data. Next box. There is also a box. Color 8. What's his position? 192, 128. 224. Let's go up this calculator. 224. So what we've done is we're going to move so X is plus going up. So X is plus 32. Plus 32. It's 256. Y is minus 32. Y is going to be minus 32. So 160 minus 32. 128. Something doesn't seem right here. The X value is not going to be this unless X was subtracted. Just make sure the utils is, well, I just check. No, plus 32 minus 32. X plus next offset X. Okay, let's just make sure we're not crazy here. And X plus next offset dot X const and Y plus next offset dot Y, and just gonna go NX and Y. Let's run this again. Didn't stop right now. Did it stop? No. Okay. Up. Next offset is 32 minus 32, and x 384, and y 128, and next box data. Where is this box? 320, 128, 320, 128, and it thinks the rect. I mean, the y is accurate, but the x is definitely not. It is in fact off by 64. It's off by 64 on the x. So there must be some error here. Okay, continue. Okay, up. Let's just step in. We'll just hit step over again. Step in. Okay, step over. So color 6. So we want, because gray, so color 10. Oh, what happened? Let's try that again. Step in. So color is 6. Is this telling that there is a box for color 6? No. So this is color 7. Is there a box? No. Color 8, we want 10. So blue, also no box. Correct. Color 9, should also be no box. Now color 10. Color 10, there is a box, which is not accurate. So let's see, box, no. This dot box is by color. Boxes by color, 10. There's one box here. 320, 128. Let's see, 1, 2, 3, 4, 5. 5 times 64 is 320, I think. So it's this guy over here. And when we want to push, there must be something inaccurate here. Up x32, y x plus 32, y minus 32. Let's make sure we're doing the maths correct here. xy is this, right? Yes. And then x, oh. Yes, because x has already been offsetted. Yep, okay, so we actually have to not pass this in already, otherwise do some offsets unnecessarily. So let's say this dot player dot x y, this dot player dot y. I'm gonna, if not player, or this player is tweening, don't do anything. And here what we're going to do is how should we call this? That's next x. All right, so we're going to rename that from nx to something else because next x seems to make sense. So that's the next offset. Okay, let's see. Let's think. Okay, tween move. Really, we're looking at box offset, right? Well, we'll call it OS for offset x. So first offset. This dot, nope. Offset for direction, we're going to pass in a direction. So we're not going to need this. We already know that. OX, x plus offset dot x, const OY, y plus offset dot y. Okay, so now we're going to check on OXOY for the wall, and we're going to check OXOY for the box data, and then NX is offset X, offset Y. Now that's NX blah blah, so here is they're using X and Y anywhere else. Okay, let's just delete. We don't need that. We have direction. We don't need this because we have direction. Same. And then same. Okay. So what should happen if we didn't do anything wrong? Let's disable this breakpoint right somewhere. No, it's already gone. Okay. This should work, but it does not. Okay, let's see why. Tween move. Tween move. Where are we? Tween move. All right, down. Let's see what it does. Okay, player X, player Y, offset. We're going down, which is going to be X3296. Great. So OXOY, given OXOY is 352,160. Okay, check for wall. Is there a wall? Has wall. False. Good. Is there a box? Box data. There is box. Brilliant. Well, this is itself wrong. Let's just, well, this is going to be OX, OY. We probably should have commented this out before we did that test just to make sure we are back to where we were before with those changes. Okay, but now this should go. Great. This does not go. This also doesn't. Oh, because we did that. Yes. Okay, so this should be pushable, but that isn't. So there is a bug, but we're getting closer. So let's see. So let's just drop this breakpoint in here, push down. Okay, the offset should be correct. Has wall. No wall. True. Is there a box? There is a box. So OX, OY, that's NX, gets box data at, so there should be no box. Next box data. But there is a box. Maybe I read this wrong the first time. All right, let's do some thinking then. Oh, no, I don't want OX. Right. But what we want is, I can't just multiply it by 2. Okay. Okay. Let's think. So the problem here is that this, of course, you can see is equal to this, which obviously is not going to be right. It's the immediate next box. But if we use OXOY here, we have not moved. That was Alexa. So we need an offset in a direction without changing the other axis. So how should we do this? Or is there another way? Is there another way? So if we know the direction, well, what we can do, let's go to this method here, and we're going to call steps. So normally it'd be one step. So if you're going left and you're going step, so steps, so that would be that. If you're going right, it would be 64 plus 32 times, oh no, steps. Let's think here. If you're going right and you're at the top left, one step, so it's not 32 either. No. Okay, let's just go back to left. If you're left and you're going left, this is one step. But if it was 2 steps, it would be, well, 64 is one step. Okay, so this has to be 0, so well, it makes more sense to call it 1. And then what we're going to do, steps minus 1. And so this is that we actually do want, so I'm going to just do tile size. We know tile size is 64. It just helps us do some math better. And so here we're going to do is, so minus 32 is the first one. So we're going to do tile size times minus multiplier, minus 32. So what this is doing is, so tile size is 64. So when you're going one step, like a normal one step, we do a multiplier, which is going to be steps minus 1, so that's 0. So 0 minus 32 is minus 32. And if we're going 2 steps, so if we're going 1, 2, this is going to be multiplier is steps minus 1, so multiply will be 1. In that case, tile size times minus 1 is minus 64 minus 32. And that looks like it is correct. And in the case of going right, at one step, it's over here, plus 64 plus 32. Now, if you were going 2 steps, multiplier is now 1. So that should be, so first plus 64 plus 64 plus 32. So it looks like it should be, I'll just rewrite it, plus tile size times multiplier. Brilliant. And then up, so if you're here, you're going up. Do you need, well, you would still multiply times negative because you're going up here. And it looks like just by deduction or induction, it's one of those logic, it would be this. Let's just double check. If you're down here, if let's say you were down here, and you're going to move 2 steps, you're going to be up here somewhere. First, the 64, and then plus 96 doesn't seem quite right. 1, 2. Oh no, we're going down. Sorry, we're going down. 64. Okay, that makes sense. Okay, so steps. And here we go. So now this is steps 1. And what we need is another offset that is steps 2. So let's bring back next offset. Next offset, and it's going to be offset for direction. The given direction and 2 steps. And so there's that, and so there's that. All right, let's see now. Let's get rid of this breakpoint. Go here, push down, okay? And push down, okay, push left. Didn't let me do it, go right, okay. This is more like it, push left, okay. Push right, okay. Push up, push left, push up. That looks good. This looks like it is working, all right. This should go down. Great, this can't. Okay, so we did not account for that. Let's do that. So we're going to actually check for a wall on the box as well. So if next box data return, and let's see, and also if this dot has wall at an x and y, also return. Not has target, has wall. All right, let's see. So we can't push this way. Just push this guy works. This guy works. And going left does not work. Going right does not work. Go left, good. Let's just see if this goes. And there we go, can't go right. I guess we should test this too. Okay, can't go up, right? Pressing up doesn't go. Can't go down. All right, so there we go. We do not have time to check the level 1. We will do that when the level is finished. We will do that in the next part. So in this part, just to recap, we've got these boxes so that you can only push a box if it is not against a wall. So you can't push it past the wall. And you can only push if there's not another box to the in front of it, depending on which way it's going. So come back next time and we are going to implement checking that all the boxes are in the right place and that the level is complete.